Okay, this is a video for Math 1, Section 1.8, Compound Inequalities. So we already looked at linear inequalities. Now we're going to look at compound inequalities. And if you think of the word compound, you should kind of think putting things together, because that's essentially what we're doing. We're bringing things, more than one thing, together. So bringing together. We're putting some inequalities together. And there's two ways that we can do that, with an and or with an or. So we need to know the difference between and. And means both. So it's essentially where we have an overlap, where it happens at the same, they both happen. Or means everything, so all. So the big difference is, let me give you an example. If I were to ask you to jump and clap, and I said the word and in between, versus if I said to jump or clap. In this case, you have to do both. In the other case, if you do one, you do the other, or you do both, it's all good. And that's really the difference. So let's look at an and used with inequalities. X is greater than 2 and x is less than 7. So we want all of the numbers that fit both of these. So we could graph each and then look at where the overlapping portion is, and that's where both happen. So if I graph x is greater than 2. Alright, here's 2. We know that that's an open dot, and greater than is this way. Then if we do x is less than 7, here's 7, it's an open dot, and it has to go less than. So we're looking for both happening, the overlap, and the overlap is right here. So the rest of this portion wouldn't work, because if I were to ask for a number, give me a number that's bigger than 2 and less than 7. Okay, and you gave me 8. Is that bigger than 2? Yes. Is that less than 7? No. So that would not work. If you gave me 0. Okay, is that bigger than 2? No. Is that less than 7? Yes. So again, that's not happening for both. But if you gave me 5, is that greater than 2? Yes. Is that less than 7? Yes. It's perfect. So that's all the numbers that we want. Okay, now let's do an or. So this one says x is less than or equal to 2, or x is greater than 7 or equal to 7. So we're going to graph both of these, and let's see what we get. X is greater than or equal to 2, so I'm going to put a solid dot at 2, and greater than is this way. Oh, sorry, I did that wrong, didn't I? X is less than or equal to 2. I was reading it wrong. X is less than or equal to 2 is this way. Then I need x is greater than or equal to 7. Solid dot at 7. And greater than 7 is this way. Now, there is no overlap at all here, but that's okay, because I just need one or the other. This would be like saying go left or go right. You can't go both, but that's okay. I said or. So the overlapping section doesn't exist, but that's okay. It's just, we just don't worry about that. It's everything. That's your answer. You just graph them both. Okay, so let's look at this with more complicated expressions and inequalities involved. For and, oh, I forgot to mention one thing. Let me go back. For the and, there's another way that we can write it. The graph is the same, but we can actually glue these together. So I'm going to take these two things and I'm going to glue them together. Why do I need two x's when I can just write 1? So I'm going to put 1x. The x's greater than or less than 7 is going to go over here. Now this one, now you guys know from the last video that I can switch this around. And I'm going to switch it around, and when I switch it around, this sign has to change. Now the reason I want to do that is because now that 2 is less than x is going to glue together with this other one, which is x is less than 7. What this means is essentially is x is a number between 2 and 7. And you can, but not including it. If they were including it, we'd have those symbols, remember? But we're not including 2 or 7. Okay, so that's what this means. These are all the numbers that are between 2 and 7. 3, 4, 5, 6, and all the little decimals in between. Okay, so just so you know about and. So and can be written separately or put together like this. The or doesn't have that. One or the other. It's just separate like this. You cannot glue them together like the ands. Okay, so back to this problem. Example 1. Solve and graph. 2 times x is greater than negative 6. So we're going to undo what's happening to the x, which is just dividing by or multiplying by 2. And so we're going to divide by 2. Cancel, cancel. X is greater than negative 3. And over here I've got x's on both sides. So I'm going to move 1 over. I'm going to subtract this x. I get x minus 5 is less than 1. Now there's only one thing happening to the x, and that's subtracting 5, so I'm going to add 5. And I get x is less than 6. So let's practice gluing these together into the compound inequality that I showed you. And so the word and just kind of disappears when we do this. So we put x in the middle. Look for the one that has the big number, which is 6. So x is less than 6, so that's right here. And now this one, I'll do this one curvy. X is greater than negative 3. We're going to switch it around. So negative 3 is less than x. And that's what we glue on this side. And that's what it looks like. So this is saying I want all the numbers between negative 3 and 6, not including negative 3 and not including 6. So I'm going to open circle at negative 3, open circle at 6, and just connect the dots. Everything in between. This is our interval of our answers. So what this means is every answer that's in here is a solution to both of these inequalities. What that means is, let me show you. I didn't mean to erase that part. Too much writing going on. Okay, let's clear some of this out. So the answers that we had, let me just drop back, was negative 3 and 6 and everything in between, right? So if I pick a number that's in here like 4 and I plug it in for both of these, I will get true statements. Here, 8 is greater than negative 6. True. Now let's plug in 4 for both of the x's here. Here would be 8 minus 5 is 3. And this is 4 plus 1, which is 5. So this says 3 is less than 5. True. So any number I would pick in this range, when I plug them into both, would work for both. Okay. Now this is an example of an and where it's already glued together. So we solve it as one piece. Although you could break them up if you want. You could take this right here, 3x plus 4 is less than 16, and then you could take this thing right here, 1 is less than or equal to 3x plus 4, and you solve both. But I'm not going to do that. I'm going to show you it's a lot quicker to just leave it as is and solve it the way it is. So here, I'm going to my goal is to get x in the middle. So I'm going to undo what's happening to the x, just like I normally would. So the first thing I'm going to undo is by subtracting 4. Now I'm not just going to subtract 4 on the right, I'm going to subtract 4 on the left. I'm going to do it everywhere. So let's write what we have. This gives me negative 3 is less than or equal to 3x. This is gone, which is less than 12. Now I'm going to undo the multiplying by 3 by dividing by 3. Okay, that gives me negative 1 is less than or equal to x, because the 3's cancel, which is less than 4. So this, you could see, if you do it this way, you get the notation back the way it is when it's combined. And I like this notation better because it's easier to graph for me. This tells me all numbers between negative 1 and 4, including, because of this symbol, negative 1. So I'm going to put a solid dot at negative 1, an open dot at 4, and connect my dots. Okay, one more example. An or, and this should say example 3. Okay, so now we have the word or here. This will never be glued together and combined like the last example. So just solve each. So we'll start on the left. I'm going to subtract 7. That gives me negative 9x is less than 9. Then I'm going to divide by 9. Actually, I'm going to divide by a negative 9. So you need to remember, we're still dealing with inequalities here. If we're dividing by a negative, that sign has to switch. So these negative 9's cancel. I get x is greater than negative 1. Or, bring down my or here. Now I'm going to solve this one. We got distribution here, so I'm going to distribute the 4. I get 4 times x plus 8 is less than or equal to negative 14. Now I'm going to undo what's happening. I'm going to subtract 8. Goes away. Negative 14 minus 8, when they're both negative, it's like adding, except negative. Then I divide by 4. Okay, and you may realize at this point that this is not going to go in evenly, but that's okay. We do need to reduce it. So that is a negative 11 halves. So I have x is less than or equal to negative 11 halves. And in order to graph that, I want to know how big that is. So I think, how many times does 2 go into 11? Well, 2 times 5 is 10. And then I have 1 left over. So that's negative 5.5. Okay. So I have x is greater than negative 1, or x is less than or equal to negative 5 halves. Negative 5.5. So just graph them both individually. X is greater than negative 1. Here's negative 1. I'm open dot here because there's no line. Go to the right, bigger. X is less than or equal to negative 5 halves. There's negative 5, I keep saying negative 5 halves. Negative 5 halves is something different than negative 5.5. Okay, negative 5.5 is right here, right between negative 6 and negative 5. And we're going less than, and I should make this a solid dot because we have the equal to. Okay, and we're done.